Good morning everyone. Today we are discussing about the topic speed of motion and payload in the subject RA 351 Foundation of Robotics. So, after completing this presentation, you must understand the concept of speed of motion and payload in robotics. So, what is speed of motion? It refers to how fast a robot or its joint can move while performing various tasks. It depends on various factors such as the accuracy, the weight of the object, and the distance to be moved. So, there are several types of speed of motion. First one is linear speed, the speed at which a point, like the end effector, move along a straight line. For example, a robot arm move its tool horizontally from point A to point B. Next is angular speed, rate of rotation around a joint or axis. For example, a robot joint rotating 90 degree in 1 second. Next is joint speed. The speed at which a specific robot move can be linear or angular depending upon the joint type. For example, a robotic elbow joint bending or extending. Next is end effector speed. It refers to the rate at which the tool or gripper move in space. It includes both linear speed and sometimes angular speed depending on the task it may be performed. Example, for cutting, welding, painting or assembly require the right speed for quality. Next is type of robot with respect to speed of motion. First one is point to point control robot or PTP. It is capable of moving from one point to another. So, and PTP robot do not control the path to get from one point to the next point. And the common application include component insertion, spot welding, wall drilling, machine loading and unloading, assembly operations, etc. Next is continuous path control robot. With continuous path control, the robot can stop at any specified point along the control path. All the points along the path must be stored explicitly in the robot's control memory. And the basic application involving typical finishing, application gluing, arc welding operation. Next is controlled path robot. The control equipment can generate path of different geometry such as straight lines, circles and interpolated curves with high accuracy. So that's all about speed of motion. Next is what is payload. In robotics, payload refers to the maximum weight a robot can carry or manipulator use its end effector without losing the performance, speed or accuracy. So the payloads include the object being picked, moved or processed, the tool or end effector or any attachment connected to the robotic arm. So, why is payload important? Ensures the robot operates safely and effectively, help determine the right robot for right task, affects speed, precision and durability of the robot, prevents overloading that could damage the robot. Payload is not only apply the weight of the workpiece handled by its robot, it also applies the weight of any end of arm tooling and bracketing integrated with the tool wrist. Payload is expressed as a weight unit with most robot manufacturers used as kilogram. If and for example of a payload carrying capacity, if a robot arm has a payload capacity of 10 kg, so it can lift a 5 kg object using 2 kg gripper. 5 plus 2 total 7 kg total weight, but cannot lift 11 kg object with the same gripper because 11 plus 11 kg object plus 2 kg total 13 kg. Only the load carrying capacity of the robot arm is 10 kg. So the robot can carry equal to or less than 10 kg. It cannot carry 11, 13 or above 10 kg. Okay. So that's all about payload. I hope you people understand both the topics. Thank you.